Now we are in the last part of the real number analysis, and why I'm taking these two together because I think I cannot explain real number without talking about irrational number. But irrational number has something that I need to talk about. Now, what is irrational number? Irrational numbers are real numbers that cannot be expressed, in ratio. That is P over Q. Now please don't forget P is an integer, Q is an integer, but Q must not be equal to what? 0. Whether you are talking about irrational number, even if it is irrational number, where what? Q must not be equal to 0. Because if it is equal to 0, then it is leaving the boundary of real number, because all real numbers are defined number. They are defined number. Now, another thing again you must note about this one now, that is to say they are real number that cannot be expressed in ratio. So you now notice that among all this one now, among rational number and irrational number cannot be expressed in ratio, but this one can be expressed in ratio. E.g. of what I'm saying is square root of 2 pi is also what? An irrational number. Square root of 3 and etc. So they are what? A simple analysis of what? Irrational, example of irrational number. Now irrational number are not what? Closed what? Under what? Addition, subtraction, multiplication and division. Please check on that. They are not closed under addition, subtraction, multiplication and division. Now that's what I mean by not what? The short term, not closed downs, meaning that not closed under division, addition, multiplication and subtraction. This one is closed under division provided the denominator is not what? Equal to 0. Then subtraction, addition and what? And multiplication. So we can call this one the dance. Better you call it dance, and you call it one not dance. Not dance. You can put it not dance, not dance. So that is how we look at it. So please take note of that. Rational number are not closed, not closed under addition, subtraction, multiplication and what? Division. Please, important point you should note. Then rational number are numbers that are not what? Reoccurring or terminating. They are numbers that are not reoccurring nor what? Not or terminating. So they are non-reoccurring number and non-terminating number. So they are non-reoccurring number or not terminating. So that not everything is negative of whatever happens in what? Rational number is what happened in what? Irrational number. The symbol for irrational number is I. The symbol we use for irrational number is I. That is to say, irrational number is a subset of what? Of real number on its own, because we don't have any. If you check the chart, I think irrational number is what we call home alone. It does not have family. Look at rational number. Can you imagine the family that rational number comprises? Because of this non-closure property and its ability not to be represented in a fraction, it becomes more difficult to study irrational number. So we study it alone alongside with real number. That's why we see, check me, place it what just like a real number give birth to 2 children. Then this one married and gave birth to one. This one did not marry. at all. That's what is including or explaining there. So that is why we say irrational number is what? Is a what? Subset of real number. Just like what we say that you can say natural number. Look at it, we want to involve the family of all this family now. And also have involved in, and I cannot say, we can say natural number is a subset of what? Integer. Integer is a subset of what? Of rational number, and rational number is a subset of what? Real number. You see, can you see the family of this now? So that means under this, we now have what? Natural number subset of what? Integer. Integer subset of what? Real number. Real number. Rational number. Rational number subset of what? Integer. But if you check this one now, just irrational number is a subset of what? Of real number. Finish. You see that because of what is complexity. Can you just even imagine the definition I've just given her? It's not close. Under that means if you operate an irrational number under any of the operation basically known, it will not give you any answer that is close, that you, something that you know that you seem to be irrational, to be an irrational number. So please take note of that. Very, very important. Now let's go to real number. Now real number now is real number. I have to clean the board now. Clean one side of the board. Let's say we'll clean this side. Let me clean this side. Real number. Number are numbers that can be represented on a number line. They are not what number that can be represented on a number line. So when we say number line, we are talking about, that means we can draw them on a number line. You understand now? Then you can represent them on a number line. Negative will be here, positive will be here. So positive on the right hand side, negative on the left hand side. So that is number line. And real numbers are close. Real numbers are close under the operation of addition, subtraction, and what the multiplication and division, provided the denominator what is not what equal to 0. The function or the element at the denominator is not equal to what? To 0. Please take note of that. Provided the element at the denominator is not equal to 0. And please take note of that. If I want to represent what, I can clean all this one now. Okay, let me clean this side. I think I've explained it. So let me clean this side because that's our chart. Now, if I want to draw what? Let me say this is real number now. Real number is what? The universal set. Then inside the real number, we have what they called oh sorry, this one should be real number. Sorry. Real number, I'm sorry for that. I said it by my mouth, I'm doing another thing. Okay, sorry for that. So this one is what? Natural number. Then inside that you have integers. Yeah, that means this one will not be what? Integers. Then that be natural number. Then inside this one will now have positive and 0 inside the integer. Then we now have outside. We now have what? Rational number. Inside the rational number, that's where non-negative number will not be. Maybe like 1/3 is non-negative. Non-negative what? Non-integer rather. 1/3 minus 1/3. It might not be, we are not saying non-negative, non-integer. Because this one now is not an integer, but it belongs to a rational number. So we cannot put it under what? Integer now. So we say that it will fall under rational number but not integer. Somebody was asking me a question, I think during this last part. Said what? He asked me a question. He said, "What about this?" When he watched the previous video, he said, "We did not analyze non-integer." That was what the boy sent me. So and I told him, I said, non-integer have already been analyzed. You know why? Because anyone that is not positive integer, zero, and negative integer we fall here. And what are the numbers? 1/3, 2/4, 8/9. Those ones are under here. They are terminating numbers, and they are also what, fraction in nature. This one is whole number, so they are fraction in nature. So that is just that. So these are it will look like. So what we have, what the non-negative number will not be here, or non-integer. Rather, non-integer will not be here. Non-integer will not be here. While everything here will not be integer. This is integer now. Everything inside here, because we have what, negative integer, zero, and natural what, number. Natural number is also positive integer. So we now have the zero will be outside. So natural number plus zero will give us whole number. Natural number plus zero plus z minus will give us what, integer. Integer plus non-negative will give us rational number. Rational number we now have outside it, we are going to have what, that are not part of the what, the circle, but part of real number. That is, now put it outside. That is to say, the integer does not belong to any of the circle. It's on its own. Can we now say that the integer and that means the irrational number will not be outside? Can we say the what? The irrational number and rational number are disjoint set? Yes. Look at it. Rational number and irrational number are disjointed. So this is what? Rational number, which is q, irrational number z, I. So they form a what they call a disjoint set. This q, where u will not be what, the r will not be what, your universal set. So please take note of that. So if I ask you now in the exam, they ask you rational number and irrational number form a disjoint set. Yes, what is a disjoint set? A set that does not have anything common. For example, if I have 2, 4 and what, 4, 5, you understand now? This set now, they have something in common, which is 4. So we can say 4 is the intersection of the two of them. 4 is the answer. But if I have 2, 4 and 3, 5, there is nothing common about the two of them. This one have different elements, So when you draw them in a set diagram, in a Venn diagram, we discover that they will be forming a disjoint set. That is what is happening. I believe I'll be able to explain that. Try my best. Don't forget, real numbers are subset of what? Of complex number. I said it in the first video. And don't forget, natural number is what? Subset of integer subset of rational number subset of real number. Irrational number is what? Is a subset of real number alone on itself. And so that is just that. Don't forget that what? All natural numbers are rational number. All integers are what? Rational numbers. Now all these numbers must be defined. All real numbers must be defined, must not be undefined. That means you must avoid what? A 0 or any undefined what? 10 in what? A real number. I believe you have enjoyed this class. We have come to an end of real number, and I believe I've tried my best to be able to what? To analyze it well. So if they ask what number does 0 belongs to, you can type it on the comment section. You can what? If they ask what numbers does exponential belong to? Exponential, you can type it in the comment section. When we can join us in the video, in the question and answer series, where you'll be knowing more about what I just asked you now, where we'll be talking about it. So thank you very much. God bless you.